Hi everyone, today we're going to cover graphing quadratic functions in standard form. This is the easiest type of standard form functions where you are able to factor the trinomial to make your graph. So let's go ahead and start with x squared minus 2x minus 3. So if you want to use a factor square, you can put your x squared up top. So x squared, it'll add up to negative 2x and multiply to negative 3. Of course, to get x squared, you multiply x times x. And to get negative 3, you can do 1 times negative 3. So positive 1 times the negative 3. And this will add up to negative 2x in the middle. So your factor is going to be x minus 3, x plus 1. So let's rewrite this as y equals x minus 3 times x plus 1. Now that it's in factored form, you can use the zero product property to find your x-intercepts. To find your x-intercepts, you'll plug in 0 for y, and then using the zero product property, you will calculate your two x-intercepts. So we'll say x minus 3 equals 0, and x plus 1 equals 0. So we'll add 3 to each side and get x equals 3. So your first x-intercept will be at 3, 0. And then subtract 1 on each side, you'll get x equals negative 1. So our second x-intercept will be at negative 1, 0. So we'll go ahead and plot our first point at negative 1 and our second point at positive 3. Now, you'll notice there was no coefficient or no a value after our equal to sign. So our pattern about the vertex table will just be left with two columns, x and x squared. As you know, we do 1, 2, 3, and 4 for our x movement, and 1, 4, 9, and 16 for our vertical y movement. So we can look between these 2 points. Halfway between these 2 points will be our axis of symmetry. And this is where our vertex will exist, right? Because our graphs are always symmetrical. So our axis of symmetry here will be at x equals positive 1. Now, you'll notice our x-intercepts are both 2 squares away from the center. See that? 1, 2, and 1, 2. So to find our vertex, we can use our table to work backward to figure out where our vertex is. So these points are 2 away from the center, meaning that from our vertex, we had to go up 4 to get to those points. So we can work that backward. We can go in 2 squares and down 1, 2, 3, 4 squares to get our vertex. And then this will make sense, right? I'll go left and right 2 squares, up 4 squares, and it's logical. Now I can fill in the rest of this graph. I'll go left and right 1 square from my vertex, up 1 square from my vertex, left and right 2 squares, up 4 is already there, right? We worked backward to get those points, and then left and right 3, up 9, which will be here and here. I cannot fit my left and right 4 up 16 on this 10 by 10 grid, so I'll stop with my 3 and my 9. Okay, let's try another one. This quadratic is also factorable. So if you need the factor square, you can go ahead and set up the factor square, but you can also just set it up by having 2 parentheses. What multiplies together to get x squared? Well, it's x and x. Then I need to figure out the number that multiplies together to negative 5 and adds up to 4. So to get negative 5, I can do negative 5 and positive 1. And negative 5 and positive 1 will add up to 4. So negative 5 and positive 1. If you want to use the factor square to help you with that factoring, you're absolutely welcome to do that. Next, I'm going to use the zero product property to find my x-intercepts. So I can plug in 0 for y. I'll say x minus 5 equals 0 and x plus 1 equals 0. So most of you at this point would be able to do this in your head. Of course, your x is going to be 5 because 5 minus 5 is 0. And on this one, your x is going to be negative 1 because negative 1 plus 1 would be 0. So my first x-intercept will be at 5, 0, and my next x-intercept will be at negative 1, 0. So I'll do negative 1, positive 1, 2, 3, 4, 5. I can draw my axis of symmetry in, and my axis of symmetry will be right here at x equals 2. Draw that all the way down. Then I look to see if I have a coefficient. I do not. So I would have the table x and x squared. So I'll have 1, 2, 3, 4, 1, 4, 9, and 16. Of course, these are 1, 2, 3 away from the center. So if I am 3 units away from the center, that means I had to go up 9 units to get there from my vertex. So I can work that backward by going in 3 and down 9 to get to my vertex, which will be right here. Now that I have my vertex, I can go left and right 1 from my vertex, up 1 from my vertex, left and right 2, up 4. And then, of course, I already have the left and right 3, up 9 here and here. And I can fit left and right 4, up 16. Perfect. Now we are going to do some standard form problems that look a little bit different, but they're still going to be factorable. So let's go ahead and try these out. You'll notice there's no c value in this trinomial, right? So there's a x squared and a negative 4x, and you're probably thinking, well, how do I factor this if I don't have anything to multiply to in the end? Well, it's one step to factor these type of problems, and that one step is to use your greatest common factor. That is the value you can divide both terms by, the largest value you can pull out of both of them. And that will keep everything as a whole number. So I'm noticing my x squared and my negative 4x both have an x in them. So I can take an x out. So this is essentially undistributing. So I'm going to divide x squared by x, and I'll be left with just an x. And I'm going to divide negative 4x by x, and I'll be left with just minus 4. So essentially what I'm doing is instead of distributing my x into my x and my negative 4, I'm dividing it out. So I'm undistributing and taking that x out front. Now, I can still do the zero product property here. So I'll make y equal to 0 to find my x-intercepts. Now, my x is going to equal 0, and my x minus 4 is going to equal 0. So my x-intercepts are going to be at 0, 0, and 4, 0. So I'll start with my first one at 0, 0, my second one at 4, 0. Of course, these are 4 apart, so to cut them in half, we'll go 2 from either square, and this is going to be my axis of symmetry. So axis of symmetry will be at x equals 2. I have no coefficient here, so I can make my same table, x and x squared, 1, 2, 3, 4, 1, 4, 9, and 16. Since these x-intercepts are 2 away from the center, that means I have to go down 4 to get to my vertex, which is right here. From there, I can work backward. I'll go left and right 1, up 1. Left and right 2, up 4, I of course already have. Left and right 3, up 9. And that's all I'm going to be able to fit on this graph. Don't forget at the end to always remember to draw in your lines and arrows because these graphs do go on forever in the vertical direction. All right, let's try one more. It's going to be similar to this one. So again, we're going to have a greatest common factor we can pull out. The greatest common factor for this is going to be x. So I will undistribute my x and be left with x plus 2. Next, I can use the zero product property to find my two x-intercepts. So my first x-intercept will be at 0, and my second x-intercept is going to be at negative 2. So go ahead and plot your first x-intercept at negative 2, 0, the next one at 0, 0. Of course, since they're 2 away from each other, we can go 1 square away to get to the center. Our axis of symmetry will be at x equals negative 1. Now again, we don't have a coefficient here, so when you don't have any coefficient listed, you can just use your 2 columns. And since we are 1 away from the center, that means we had to have gone up 1 from our vertex to get our square. So instead we can go in 1, down 1 to work backward to our vertex. And from there we can go left and right 2, up 4. And left and right 3, up 9. and we'll have our graph. All right, so that's going to be it for the easy version of graphing quadratics when they're given to you in standard form. The reason these are simple graphs is because all of these trinomials and quadratics